purpose of this video is to give a broad overview of precursor analysis. By introducing the concept of precursor analysis, the process in which the analysis is conducted, and explaining the many benefits, it will be shown that precursor analysis may be the next leap forward for safety in the construction industry. The formal definition of precursor analysis is that it is a systematic approach to address catastrophic accidents that are usually preceded by precursor events that, although observable, are not recognizable as harbingers of a tragedy until after the fact. The origins of precursor analysis can be traced back to catastrophic events such as the Challenger and Columbia space shuttles, 3 Mile Island, and the London Paddington Station train crash. Although these incidences seem to completely differ, experts began to ask the question of how to predict and prevent these disasters. After investigation, all of these extreme events had one thing in common: prior indicators that were either ignored, deemed harmless, or completely missed. Had these prior indicators, or precursors, been recognized and appropriately managed, the disasters could have been avoided. In reaction, each of these industries created a precursor program to be able to predict and prevent future catastrophes. All of these programs have the same basic approach. Failure sequences for extreme events are broken down into precursory information, which is then utilized to predict and prevent potential extreme events or fatalities. So how might precursor analysis benefit the construction industry? The construction industry's extreme event is worksite fatalities. In the past 10 years, the number of injury cases has steadily diminished through implemented safety techniques, but the fatality rate has slightly increased and plateaued in recent years. The aim of precursor analysis would be to predict potential fatal accidents, much like other industries predict their respective extreme events, and ultimately prevent fatalities on the worksite. This raises the following research question: are there precursors or leading indicators of low-frequency, high-impact events such as fatalities or near-fatalities in construction? If so, what are they, and how can they be identified, analyzed, and implemented to prevent serious injuries? To begin, what exactly is precursor analysis? Precursor analysis involves precursors that are inherent to the nature of work being performed. This means that precursors are not a managerial problem and do not involve leading indicators such as poor housekeeping or improper PPE. Rather, the analysis involves unavoidable mechanisms of the project itself. In addition, precursors are observable project attributes that can be observed long before the accident sequence is triggered. Most importantly, precursor analysis is a predictive tool that is a proactive safety measure. Precursor analysis doesn't simply assess lessons learned from previous accidents, but instead uses precursor information to predict future accidents that may or may have not occurred in the past. The first step in most precursor analyses is the creation of an event database. When individual organizations use actual fatality data, the reports are very few and far between, making it impossible to identify patterns or meaning from this data alone. The beauty of precursor analysis is that it does not have to rely only on fatalities to deduce precursor information. Potential fatal incidences can also be drawn from less severe injuries that had the potential to be fatal under slightly different circumstances. The exact same deduction can also be made for near-miss reports. When we consider all these sources from multiple organizations, a large enough event database can be created to be statistically relevant. This has yet to be done for the construction industry despite its significant benefits. The next step is to extract precursor information from each actual or potential fatal event. The extracted precursors from each event are typically combined into their own data set in which two assessments can be performed: a qualitative assessment and a quantitative assessment. The qualitative assessment generally involves a panel of experts looking at the resulting precursor data to either find patterns and trends or specific events of interest. The quantitative assessment can get very sophisticated by utilizing a variety of statistical techniques such as regression trees to mathematically explain event or fatality sequences, generalized linear models to mathematically predict fatalities, principal component analysis to relate precursors to space and time as well as precursor interaction in space, and lastly Bayesian network analysis, which models precursor interdependence. All of these techniques can be lumped together as methods for predictive risk modeling. Such precursor information can help with assessing and managing risk of fatalities and focusing efforts that target precursors as they emerge, before they can contribute to the risk of injury or fatality. In summary, precursor analysis of severe and fatal events has the potential to be a large step in safety for the construction industry. It allows companies to be proactive instead of reactive with their project safety, improving organizational awareness. The proactive approach makes precursor analysis a cost-effective option by influencing a project early in its life, as well as avoiding medical, legal, or increased insurance fees. Lastly, hidden causes for accidents are often revealed during the analysis, which provide a greater understanding of the nature of fatalities and how they can be prevented. Other sophisticated industries have been experiencing the benefits of precursor analysis. It is time for the construction industry to emerge as a leader.